Hello everyone, today I'll be talking about nuclear fusion energy, comparisons and present situation. So before I start presenting, I'm going to first introduce myself. Hello everyone, my name is Adam. I'm a rising senior in Westmount High School located in Campbell, California. I am 17 years old and I'm mentored by Uday, who helped me a lot for both this presentation and my research paper. So two questions I'll be answering for this presentation are, how does nuclear fusion compare with other forms of energy like coal, solar, and nuclear fission? And what resources do we need to dedicate to it in order to develop this energy to its maximum potential? For topics of discussion, I'll be talking about the scientific description of nuclear fusion, comparing it with other energy types, and its current situation, plus the scientific obstacles that fusion still faces today. So what is nuclear fusion? Nuclear fusion is energy generated by fusing two or more nuclei together. The materials needed for this process are deuterium, which is shown here as D, which is the second isotope of hydrogen, and tritium, shown here as T, which is the third isotope of hydrogen. And the fusion energy released during this process is due to the loss of mass, as the sum of the masses of the reactants will always be more than the sum of the masses for the products, with the loss in mass being converted into energy. And I have decided to put this graphic here as I feel like it's very interesting to observe how the protons and neutrons rearrange themselves during this process. So what is required for nuclear fusion? The temperature needed for this process is 100 billion degrees Celsius. It also requires intense pressure of 10,132.5 millibars, which is 10 times the atmospheric pressure of Earth. Additionally, the fusion fuel, which is the deuterium and tritium, needs to be contained for at least 4 seconds in order for fusion energy to actually start generating. For the picture for this slide, I have decided to put a picture of a star because stars are the main places in our universe that can constantly generate fusion energy due to their high temperature and intense pressure. So what are some of the advantages of nuclear fusion? The first advantage is that it's a renewable clean energy, as shown in this graph over here. This is a graph of the carbon emissions avoided by fusion power, by nuclear power, and currently nuclear power is being dominated by fission energy. So with the help of fusion energy, we will be able to avoid more carbon emissions in the future, which is good for our environment. Additionally, fusion can generate more energy using less amounts of fuel, where 1 kilogram of fusion fuel generates the same amount of energy as 10 million kilograms of fossil fuel. Lastly, the materials used for nuclear fusion can easily be harvested, with deuterium from seawater and tritium from lithium, which is one of the most common sources found on Earth. So comparing it with coal, a pearl for fusion is its energy output, where it generates 4 million times more energy than coal. Another pro is that fusion generates clean energy, so the energy generated from it won't harm the environment. A con for fusion is that compared with coal, the conditions needed for fusion is much more difficult to achieve, making coal a more appealing option today. So the second energy we're going to be comparing fusion to is solar. Both of them are clean renewable energy. A pro for fusion is that it can generate energy at any time, while solar is dependent on both the sun and the weather. Additionally, fusion takes up less space because for solar, in order to generate energy effectively, there will be a lot of solar panels spanned across a very large amount of space, which nuclear fusion does not need. For fusion, it only requires a nuclear fusion device in order to generate energy. A con for fusion is that solar energy can generate energy easier and has easier requirements compared to fusion because fusion has the intense pressure and temperature. So comparing with fission, which is what dominates fusion power, so fission is the energy that dominates the nuclear power today. So compared with fission, a pro for fusion is that it has a faster energy generation with each fusion reaction with each fusion reaction generating 4 times the amount of energy of a fission reaction. Another pro for fusion is that it is safer compared to fission because fission has the ability to cause chain reactions, which is very dangerous. So chain reactions is basically, so fission itself generates energy when a neutron enters a heavy atom. And as a result of that, the atom becomes unstable and splits apart into 2 separate atoms. And sometimes the neutron being ejected might enter one of the lighter elements, and it will cause the nuclear fission process to undergo again, and it can keep continuing on. And this repetition of fission energy can cause an influx of so much energy that it causes a nuclear explosion, which is obviously very dangerous. And the chain reaction is impossible for nuclear fusion, which is why nuclear fusion is much safer. And this is the main equation used for fission on Earth. A con for fusion compared with fission is that for fusion, the conditions for fusion is much more difficult to achieve. As for fission, you only need a heavy atom and a neutron. So for the current situation, there are 23 nuclear devices under development. There's also a rising amount of fusion companies around the world. As you can see here, within the last 14 years, the amount of fusion companies increased fivefold, which is very good to see. Um, the funding for nuclear fusion from the US government is declining, which is something that is sort of unfortunate, which you can see here, where the current funding for it is only one half the peak funding. So some of the main scientific obstacles of fusion today are the plasma heating and confinement, which is, so let me first introduce what this picture is showing. So this picture is showing an image of a tokamak device, which is a device that generates fusion energy. And within this device, it holds, like during the nuclear fusion energy generation process, it holds plasma, which is the state of matter that the fusion fuel is in when it reaches the required temperature and pressure. And while holding plasma, the surrounding materials will get damaged a lot of the time. So currently we're trying to find a way to either find a material that won't get damaged from the 100 billion degrees Celsius requirement and the plasma, or we're trying to find a way to, like a method to reduce as much damage from the plasma and the intense temperature as possible. The second obstacle faced by nuclear fusion today is maintaining the fusion reaction, because even today, maintaining the 100 billion degrees Celsius temperature mark is very difficult, especially for a long period of time. The last obstacle is finding an effective way to store tritium, because after tritium is harvested, it is in the form of a gas, which makes it very hard to store. Additionally, tritium is harmful to humans, as it is known to cause cancer to humans. So we're trying to find a safer way and more effective way to store tritium and transport it for the nuclear fusion. So conclusion, some advantages of fusion is its quick energy generation rate, safety, renewable, and clean energy. Some disadvantages are the extreme temperature and pressure requirements. The resources needed in order to develop fusion even more is basically more funding in order to help solve the main obstacles as I previously mentioned. Thank you very much.